Hello, hello, testing, testing. E aí, pessoal, beleza? Bem-vindo a mais uma aula. Deixa eu verificar aqui se tá. Sorry, hello everybody. Welcome to another class. Let me verify if everything is working fine. Sorry for the Portuguese. Okay, because I have another training that I do that is in Portuguese. Sorry. Let me go to my channel and see if everything is working fine. Okay. Verificar aqui se tá. Sorry, hello everybody. Welcome to another class. Okay, it's working fine. So in this today class, we will solve the question number 18. So the idea here is to read an integer number with 5 digits and generate a new number with the digits in reverse order. So just to make sure that we always clarify some question that we can make here, or read an integer number with 5 digits. Always 5, and maybe yes. So we can assume that there is no zeros on the left. Let's assume initially that yes. So the number will be something like 1, 2, 3, 4, and 5. If this is the input, the output should be something like 5, 4, 3, 2, 1. If the input was 5, 3, 2, 4, 1, or 54,321, the output will be 12,345. If by any chance it was like 33,666, the output would be 6,633. So this is kind of like I said, we are trying to build our fundamentals. We are trying to learn how to solve problems. And if you ask this to any software engineer, there is an easy way to do that. Use strings. We convert to string, we reverse that. But what I want to do here is like to plant a seed in our mind that will allow us to solve a problem that they are easy. Any kid can do this. If you teach like even maybe a 5 years old, 6 years old, oh, I want you to give this number, I want you to print it in reverse order. It's easy. But that is what code is about. There is a lot of easy, medium, and complex problems that we need to explain the computer in little steps how to solve it. So please don't think that everything gonna be learned here is about math, is about numbers. No, this is just to show you some basic stuff, because at the end of the day, we're gonna be doing calculation. So if you're gonna work in an online store, you need to be able to calculate discount, percentage, tax, total. So it's some basic math. So let me go here and open our design application. So we'll be using this guy. Let me put like here in the right side. And then I'll do this. I will hide this for now. And I can do this here as well. Oops, not this. I want this guy. Oh, I see, because they are attached. So how I do this, and then I go back. Now I can do something like this. You get this guy here, now you do something like this. Okay, this is cool enough. So now I think we have enough space for our code and for our design thing. So let me do this so I can read comments or anything. So remember, doesn't matter how easy you think the problem is, invest some time in working a solution. And remember, like anything else, we may use what we learned already to make it easier to solve new problems. It's what we are doing here. We are building up a library of solution, of tools that you can use when you get a new problem. Don't think that we be always solving new problems. Like sometime, when even after a couple years of experience, we don't get anything really new. Depend where you are working, it's just almost the same thing with a different flavor. So may happen that after a couple years, the work get very easy, sometimes boring, and then people move to other challenge, or then people like, okay, I'll be here, and then explore other. They improve other skills, communication skill, leadership skill. They go up. So I hope we get to this point where you get bored to solve those problems. But let's go there. What you need to do is, okay, we'll have like on the right side, let me do something real quick here. I go to the format and oh, not this. I meant to click in the line format, line, and then I'll make the ticker a little bit more. Okay. So we'll have like on the right side is kind of our program. Let's do something like this. No, I don't want a new one. And on the left side is our input and output. So let's do this. What is the ingredients of this problem? What is the input? It is an integer number. Integer number. What is the output? We could say that the output is another integer number. But this one is reversed. And now it's up to us, okay, what can we do to achieve this, to reverse all the digits of one number? Remember, we cannot use anything advanced because we didn't learn yet. There is a lot of things, almost everything we learn here up to the end of this training. Later on, we learn something that make easier because that is how we evolve, we get better. But we need to learn from the ground up. It's like when we are training, if you are doing a good training, you have to be slowly be doing exercise that emulate what you're gonna do during the competition, during the game. But in some point you have to go higher. For example, if you're gonna play basketball for 30 minutes, you train way more than 30 minutes. For example, someone that is going to run 100 meters usually take 10, 12 seconds, but they don't train only 10 seconds. They train multiple times a day. They do a lot of different things, but in the competition day, they do the best to win. So this is what we're doing there. We are doing those all kind of different exercise, push-ups, pull-ups, like sit-up, whatever, to get our muscle, our brain muscle better. So later on, when we're gonna do the competition, we are in a better shape. So, okay, what do you know so far that will allow us to do this? So let's imagine that we got a variable here. In this variable, we had that simple case, 1, 2, 3, 4, and 5. So this is our numbers. What we need to do here? Let's think like this. A good tip how to find a solution is forget initially a little bit about coding, but try to break down the solution in small steps that we can replicate with what we learn in coding, the basic operation. So far we learned basic operation. Multiplication, division, addition, subtraction, and integer division. So let's think like this. Okay, I have this here. I need to generate a new number that is the inverse. So we could say, okay, what if we remove the last number and then we add it to this target number? Then what if we remove the last number from this and then we add it to the right of this? Again, oh, let's do, yeah, again, I will get the last one from this and then I will add to the right one of this. Basically, is how any bar you do. Then let's get the 12, the 2, and then let's put here. And for the end, we get the 1, and then we put the 1 here. So we have our goal, that is that number reversed. That is the part of teaching coding that is hard, because if we just come with the solution to the code, will make sense, but maybe it's not helping someone that is new and how to solve another problem. So what I can do here is give some ideas. So basically what we need to do is, okay, let's go back to the original number, 1, 2, 3, 4, and 5. What we want to do here is we want to create maybe like, I put here like a box just to say, oh, this is a variable. Let me do the same here. Let me show this. This is a variable. And this variable will contain 1, 2, 3, 4, and 5. 12,345. What we want now is a new variable, or maybe new variables in the plural. One here, another one here. What we need to do is, oh, sorry, let me remove this one. What we need to do is, we need to get this last digit here and move to one place. Let's do this. Imagine that we have one variable just to store the last digit. Imagine that we get that 5 and then we put here. Now what we need all the digits except the last one. So we need to find something, some operation that you bring all those numbers except the last one and put here. So we want to have 1, 2, 3, 4, and 5. Oh, and 4, sorry. And now let's imagine that we need the output variable, the one that we want to return. So this is the variable that we will return in our code. What we need to do now, we need to get this 5 and put here. So imagine there is nothing here, we can just assign. We can say, okay, get this variable and just assign to this one. So in this case, we will have 5. So we have to figure out which operation gives me the last number. If you remember about integer division, let's do this here. I will do this. Let's put 1, 2, 3, 4, and 5. And if I try to divide this by 10, let's see what we get. Oh no, let me be more, I put, oh, sorry. Let's divide by 10. If I divide this by 10, how much you get? Okay, we'll have here 1, 2, 3, 4. So this will make the 12,340. this is what you have here, 1024 0, because this will be multiplied by 10. Let me move this a little bit here. So remember, every time we divide by 10, we're going to extract the last digit. All the digits except the last will be the quotient, and the last one, let me make this prettier. When we do this, the remainder or the mod in this case will be 5. Oops, sorry. We all need to understand this math clearly, because if you don't learn this, you're going to have trouble later on. I get this number, 2,345, and I try to do the integer division by 10. So dividing things by 10 is obvious that what's going to happen. We need to get like all these numbers, 1, 2, 3, 4, multiply by 10. So you have like 1, 2, 3, 4, 0, and then you make the difference. So we already know that to get this, the last digit, is the operator percentage. Remember that you learned the remainder or the mod is percentage. To get the quotient is just the integer division, slash by 10. So now we figure out how to do this, how to get only the last one. So if I type here, will be like, let's say this number percentage 10. That will be this. What is a reminder? So this is how we extract the last digit. And after we extract the last digit, we're going to update this guy. And to update this guy, let me try to do something like this here. Let's see if it's going to work fine. This guy will receive okay. We'll receive this operation. Number dash 10 slash dash 10. So it's the integer division. So now we have the two steps that we need, but now there is something else. Of course, this will be inside a loop because we only extract the last digit. And now I have to say, okay, how to extract the 4? We're going to do the same thing. So now if you do the same operation, number mod 10, we'll get 4 here. And now there is one thing else. When we get this, we want to add it to the right side of the 5. We cannot get a number, just say, oh, add it to the right number. But which operation we do with 50 that we can add 4 on the right side of 50? Well, if we multiply by 10, 5 will become 50. And now we can add this digit, so it become 54. Then we go to the loop, we do the same again. This guy receive number divided by 10, so that will be 1, 2, 3. We do again, extract the last digit, that will be 3. Again, we multiply this by 10 to open space, and then we add 3. So it will be like this. So actually, we found a logic. Between a loop, we will do those steps. So it's very important that we can break it down and understand that, okay, now I know how to do each part, and now we're going to put together. And when we're going to put together, we're going to figure out which order we should do it. So let's do this. Now that I have some idea, I go to number, will receive integer from this input. And I will put here, the input will be number. Okay? Once we have this, we may want to keep the original number. So as we have the original number, we'll create a new variable. I can call this backup or auxiliary. So this number will be here. Later on, we'll learn a better way to do this. We don't know yet, but what we can do is this. We can create another variable called inverse number, and let's start with 0. And I explain why 0. Now let's do this. Let's extract the last digit. Let's call a variable here like last digit. And we saw the last digit will be, let's use this guy here, aux, or let me call number, I will call number cop. Or better, let's forget this. Let's just don't care about this now. Later on, we're going to say, let's use the same number. So what you do is we gotta get number mod 10. So this will give me the last digit. If it was 1, 2, 3, 4, 5, we'll get the 5. If it was 1, 2, 3, 4, we get 4. So it's very important to send this. So every time we get the last digit, we'll do this. The inverse number will receive the same number multiplied by 10 plus the digit, plus the last digit. Remember, it starts with 0. So it'll be like 10 multiplied by 0 is 0. And then we sum with the first one. That will be 5 or whatever we get there. So now this number will be the last digit. We didn't learn how to do repetition yet, but this is just to plant a seed. So now that we extract the last digit, we want to update because we already used the last digit. So I want to say number will receive a number divided by 10. I want to get now everything except the last one. Now we have a new number without the last digit. So we'll do again. Let me separate this. We'll do again. Last digit will receive a number mod 10. So let me show what is going on in here. Let's start this. I removed those things here just to make it easier for us. We start with number. Imagine that I type 1, 2, 3, 4, 5. And let's do this. This variable here. Let me give the name so make it easier for us. So this one here is number. Now will be clear, I promise you. This will be number. This one will be digit. And this one here will be inverse number. Now I promise you, everything will be clear. Everything is gonna be alright. Don't worry about a thing. If you like reg, I love reg. So what we did here, we said, okay, last digit. Oh, let me do this. This guy is nothing yet, and this one is nothing yet. We say, okay, inverse number receives 0. And then we say last digit will receive number mod 10. So this has to be very clear for you. If it has not yet, review the class about integer division. So number mod 10 will be 5. Now that you have 5, see, we have 5 here. We'll get this inverse number. In this case, we can just say this. Look, maybe to make it easier. The first time, we can just say add 5 here. So now we go to the next line. Our next line, we have to update the number because we already used the last digit. So I say, okay, the new number will be the number divided by 10, the integer division, because now the number will be like this. And then again, I will do, okay, last digit, we receive number mod 10. So now we'll get 4. Now that we have 4, we need to bring the 4 here to the right side, just to show this beautifully. Oh, come on, what is this here? I don't want to navigate. Whatever is here, you want to bring here to the right side. Is that why we'll get the inverse number? We say, okay, that inverse number will receive itself multiplied by 10 plus the last digit. So what we did, okay, we got inverse number, we multiply by 10, so inverse number now is 50. And then we add 4, so now it became 54. So we already brought 2 numbers. Now let's prepare to the next one. How we prepare? Well, we already used this last digit. So I want this number to become everything but not the last one. And we already saw that it's just to get number. We receive number divided by 10. This is good because I'm planting a seed in your mind for something that you're going to learn soon, repetition. So you don't need to do this multiple times. We just need to put in a command that repeats itself. We're going to get there. Now what's going to happen? The number will receive number divided by 10. That will be 1, 2, 3. Again, we'll do last digit. We'll receive a number mod 10. So last digit will receive the last one here, that will be 3. And now it will be easier for you to understand the next step. I have 54. 54 has to become 543. Is that why we have to do inverse number will receive itself, inverse number, multiply by 10 plus last digit. 54 will be 540 plus 3, 543. And then you can be asking yourself, oh, how I could come to this solution? It's normal. We are learning. You are learning. You are not supposed to figure out everything. But now that you know something else, will help you solve new problems, like learning math or anything. Like, you cannot just think everything someone is teaching you, you should supposed to to guess or to find out. We have to work on those libraries, then we can just copy and paste from our mind. So now we have like 453, and then we have to again do the same thing. Look, it's so silly that I say, okay, I will copy this. And this is what will open your mind to a repetition command, because we need to do exactly the same step. We'll get number and divide by 10, so number will become 12. We extract the last digit, that will be 2. Then we multiply this per 10 and then add 2. And now we'll do the last run. So we did 5 times the same thing. Don't show this to any programmer that is your friend, because you tell this guy is not teaching you coding, because this should be repetition. But tell, oh, we didn't learn repetition yet. The teacher was trying to make our mind be prepared for repetition, because something like this, if you're smart, we're not going to do 5 times. You just put in one place to do 5 times. So when you get there, it'll be easier for you to understand. And now the last step will be the same. Number, we receive number divided by 10, integer division, so it will be 1. Last digit will be 1 divided by 10, the rest, the mod, that will be 1. Then we get this, multiply by 10 and sum with 1, and then it will be like this. So now we can say, okay, print, let's do interpolation here, inverse number will be equals to, and here we put the inverse number. Okay, so let's debug so we can see how this goes. And as we are going to debug, we need to show here. So I will make the IDE screen. Oh, sorry, I'll keep this one here. I'll make the IDE screen bigger so we can see the debug. Oh, I can just make this size here. It's fine, I think. Let's see. Now let's run F5 and let's see how it goes. So let's type the number. Let's use this example, 1, 2, 3, 4, 5, and we are here. So what we're gonna do, we're gonna get inverse number and initialize with 0. Because 0 is the neutral value for multiplication. Whatever multiplied by 0 will be 0. So see, our inverse number is 0. So now let's extract the last digit. Last digit will be number divided by, not divide, the rest by 10. See, we got 5. Now we get the 5 and say, okay, the inverse number starts with 5. Let me make a little bit of space here. Now we do the same. We're going to get, okay, number will be, or will receive a new value that is number divided by 10. So when we divide the number by 10, we just remove the last one. So after this line, number will be 1, 2, 3, 4. And then again, we extract the last digit. That will be 4. Once we have 4, we're going to say, okay, inverse number will receive itself, that is 5, multiplied by 10, plus the last digit, that is 4. So inverse number became 50, plus 5 will be 54. And now we do same thing again. We update the number, so the number became 123. We extract the last digit, that will be 3, and then we get this 54. We convert to 540, and then we sum 3, it will be 503. And now, I believe you got already. We're going to update the number to become like 12. We extract the 2, and we add 2 to the right side of the inverse number. And then we do the last time. And now our inverse number is 54,321. And then we print it. So now let's do some testing with different values. So we'll test with 54,321. Let it run. And then it's there. And let's test with this 333,666. 333,666. So remember when I told you that in the interview, it's very important that you can upfront ask a question like this. Okay, does the number always have the 6 digits, or could be just 1? Could be just 12? Could be 122? Or could be the number something like this? So the interviewer will tell you, no, we don't care about this. Of course, this is not a number, no? I could imagine that, okay, let's imagine that if I type this, what should happen? Because in theory, this should be, do you agree with me? This will be, oops, sorry. This one would be, and this one, of course, there is no 0, 0, 0, this will be 1. And this one here, similar, will be just 9. We didn't thought about this, but let's see if make any difference. So let's test with those. I remove the breakpoint just to make faster. And then I run. And look in here, let's try the 10,000. So 10,000 work fine. Oh, not, sorry, 10,000. I was supposed to test this one. 10,000 is right. Let's run again. And let's put like 0, 0, 0, 0, 1. And this works fine. Because the math is the same. If you pick, I want you to do this. Get this number here and try to do the same logic. Because when we try to extract the last digit and the rest, like you see that it does work. And I want you to understand how I work. So sometimes, even if you don't think about some corner case, but we solve the problem in a generic way, we work in some case that we are not even expecting. So let's run again. And let's test this case. Remember that 1 and 0, 0, 0, 1 is the same. So if I just type 1, it would be the same. Because for any number system, 0 on the left means nothing. It's just a waste of space. And now let's test that 1, 2, 3. Oh, sorry, I'm typing wrong place. 1, 2, 3. And then look, 1, 2, 3, 3, 2, 1, 0, 0. Oh, we jumped one. No, that was 12. Oh, come on. 12 will be 21,000. I want you to make sure that you get those cases and you run here to see what happened. Actually, let's do together, okay? So imagine that our number was this, 1. So let's do our algorithm, our logic with this, with 1. Okay, I will hide this. Oh, actually this. And let's see, we got our input and they used to type 0, 0, 0, 0, 1 or just 1. And then you're going to say, okay, let's get the mod of this number by 10. So let's see if we get this division. So let's go back here. No, let's do another one. So the number is 1. So F12, 1. And then we try to divide 1 by 10. Whoa, it's sideways. How? So look how is the math. How many 10s we need to make 1? 0. Because even 1 10 is bigger than 1. So our division here will be 0. This is very important for us to understand. With 0 10s, how much we have? 0. So what is the remainder? The remainder is 1 itself. So that means this operation will return 1. Okay? Now we go here. Number will receive a number divided by 10. So 1 divided by 10, what is the quotient? Is 0. So number will receive 0. And from now on, every time we try to divide 0 by 10, the quotient will be 0 and the remainder will be 0 as well. So all this operation will return 0. And what we do is we multiply number by 10 and we add digit. That digit will be always 0. So we multiply by 10. Oh, sorry. Multiply by 10 again, by 10 again, and then let's time. Is that why 1 became 10,000? Because we add 4 zeros on the right. Cool? I hope this didn't confuse your mind. Don't think that code is all about math, but believe me, I'm planting a seed in your mind that will help you to deal with what you learn in the future. Don't get demotivated if you think, oh, come on, there's a lot of writing. This for us in 3 months, 2 months, will be just one line of code. We don't do this in real life. This is just exercise. It's like you want to be a runner, you have to do push-up because you need strong arms to speed it. During the competition, you're not going to do pull-ups. You're just going to run. It's what we're doing here. This is our pull-ups. This is our like sit-ups and whatever. Okay, so believe me, I have been teaching coding to thousands of people, and this works. I don't want to come here and give you the best final solution to show, see how this is nice. I don't want to promote myself at all. I want you to understand those little steps because later on it will be easy. It's like a coach. Imagine that we're going to train box with Mike Tyson and say, okay, let me show you. Let's do a 1 round sparring. Then I go show you how good I am. The guy is not coming to the next training. You have to start. Okay, put your gloves, stretch your arms, learn how to hit the punch bag. Don't use your all power. You're gonna hurt yourself. It's kind of you correct the movements, and then later on you do some shadow box. A few months later on you do some light sparring, and then you can do some sparring. And after maybe a year, you can think, oh, I can do some competition. So remember, coding is the same thing. Don't believe anyone that is going to teach you code in a few hours, few weeks, or few months. It's the same as I tell you, oh, I can prepare you to go to a box competition in just 1 month. No one will dare to do that. So don't believe that in code. Take time. I would say that minimal 2,000 hours to consider yourself a junior developer. Every coach has the same. They know how many minimum hours in average one athlete will be ready to competition. And if he try to jump the steps, you create a big problem. The same here, okay? Well, thank you for participating. God bless you. See you next time.